Okay, so we've got a problem here, sine of 100 to the k. And this is a series going with k equals 1 to infinity. It looks super aesthetically pleasing, and it's actually really easy. It's very easy because we know that this is geometric already. It's already in a really nice form where you've got something being taken to just an exponent. This is going to be geometric, and so when we have a geometric series, we know to ask, in order to find out if the series converges or diverges, we ask if the common ratio, if its absolute value of this common ratio is less than 1. If it's less than 1, then we know this converges. If it's greater than or equal to 1, then we know it diverges. So in this case, our common ratio is sine of 100 because that's what's being taken to that exponent. We don't have to do anything to it. Sine of 100. If you actually evaluate sine of 100, it's like 0.98 something. So that's actually less than 1. And since it's less than 1, this is going to converge. Converges. If it's going to converge, we have to know what is it converging to. So for that, we need this formula, a over 1 minus r being our common ratio. So we could already plug that in, 1 minus sine of 100. What is a? A is our first term. How do we find our first term in a series? Is we plug in whatever is given as our first value of k, or whatever variable we're playing with. We plug in that in here, and whatever we get, that's our first term. So in this case, we plug in 1 into that k over there, and we get sine of 100. So this is what it converges to, sine of 100 over 1 minus sine of 100.